105 in the notes and starting to look at molecular formulas. So a molecular formula shows the actual number of atoms per element needed to build one molecule or unit of a covalently bonded substance. Molecular formulas can reduce to the empirical formula. A molecular formula is a whole number multiple of an empirical formula. So take a look. We have C6H12O6. And when you take a look at this, C6, 12, and 6, they are each divisible by 6 to maintain a whole number. So if you divide each of these subscripts by 6, it becomes C1, H2, O1. Or we would simply write it without the subscripts of 1 as CH2O. So this would be the empirical formula. This is the molecular. So a molecular formula many times can be reduced to an empirical formula. However, some molecules, their molecular and empirical formula are exactly the same, like water. You can't reduce a 2 to 1 any further than it already is. So let's take a look at a couple of multiple choice questions here. So take a look. Which set of formulas could be molecular formulas with an empirical formula of NO2? So meaning that empirical ratio is 1 to 2, and it has to be in that order, 1 to 2. So when we take a look here, 2 to 2 is 1 to 1. It doesn't match. So I know A right away, not a possibility. When I took a look at response B, okay, I see 1 to 2 here, so that matches. So I have to look at the second one, and it says 2 to 5. The only thing it can be divisible by is 1, so it is 2 to 5 does not match. So that one makes B not a good answer. 2 to 3 is only, both of these together are only divisible by 1, so 2 to 3 does not match 1 to 2, so C is not a good answer, which means D should be the correct answer. So let's check. So NO2 means we have a 1 to 2 ratio. Good. Now we see this is a 2 to 4, and since they're both even, they're both at least divisible by 2, which would change it to an NO2, which is a 1 to 2 ratio. So D is our best answer. Let's take a look at the we do question. It says, which molecular formula is correctly matched with its empirical? So that means they need to have the same ratio. So here we go. In example A, it says 2 to 2. Well, if we reduce it down because they're both even, it becomes 1 to 1. Where the other one, has a ratio of 2 to 1, and since 1 is even and 1 is odd, they're only divisible by 1. So this is a 2 to 1. These do not match. They are not the same. So A is not a possibility. Take a look. We have a 2 to 5. 1 is even, 1 is odd, and so they're only divisible by 1, so we have a 2 to 5. And take a look. We have another one which is a 1 to 3, and they're both odd, so they're only divisible by 1, so we have a 1 to 3 ratio. They are not the same. Take a look at letter C. Both the subscripts are even, so they're both at least divisible by 2. And if we do that, it becomes a 1 to 2. And our second one, it is already a 1 to 2. So they are the same. So C should be our answer. And if you just take a look at letter D, just to double check, we notice we have an even and an odd. They're only both divisible by 1. So we have a 2 to 1. And over here, we have 2 and 3, and even and odd, they're both only divisible by 1, so we have a 2 to 3 ratio, so they are not the same ratio. So C is the best answer. You try the remaining you do questions, check your answer with your teacher.